Han Shun presents chemistry. We have done these 4 episodes last week. Today's episode 5 will be about the atomic model's history. Changes times 6. Let's get started. Set aside the music, and today we'll be going into the atomic model's history. And by the way, until today, there are 6 changes to it, and I have already gotten some photos downloaded of the scientists who created it. So there are 5 scientists, mainly because, one of them did 2 changes, but let's just do it! Alright, first major scientist of all today right now, we have Democritus. Democritus! This guy's name is Democritus. And in 500 BC, actually I'll call it BCE, she created something called the atomic theory. It was essentially that basically stuff was created from just fundamental particles. Now these particles were just like little balls in his day, and now there wasn't a lot of proof for this, so it was discarded. But however, it was going to be for the next truth. Next up, we have John Dalton, not to be confused with Harry Potter. I mean, look, the glasses, he just needs a scar, and he'd be perfect. He'd be a perfect Harry Potter if he just had a scar and a wand and some robes. Scratch out the robes, Hogwarts robes. But, setting that aside, way later, time travel portal, we come to John Dalton. And in the 1800s, he proposed something called the solid spheres, which were actually really close. He actually essentially suggested that Democritus' theory was correct, but he just needed one vital change, that they were spheres. And different types of spheres like these correspond to the different types of elements that we found on the periodic table. Alright, next up we have J.J. Thomson. And he, in 1897, a little while after John Dalton proposed this theory, he actually proposed the plum pudding model after actually having done a lot of experiments. And because he said that these couldn't be solid spheres, or else it would be collapsing. And they must have contained some negatively charged particles, which we now know today as electrons. However, Dmitri Mendeleev would have been very angry at that idea because he didn't believe in anything that he couldn't see with his eyes. Weird, but typical Dmitri. So instead, he proposed the plum pudding model. Because, why we call it the plum pudding model was because it looked like a ball of the casual plum pudding. And let me just show these little balls as electrons, not to scale, by the way. Alright. So this green highlight, the places where this green highlighter is highlighting, except for the places where the balls are, is the general ball of a positive charge, the green area. And the red areas are the discrete electrons. And if you compare it to a little slice of plum pudding, you can actually see all the similarities, that little stuff inside and that little discrete charges outside. You can see why we call it the plum pudding model. Looks so similar. Alright, next up we have to go let's see 10, 12 years into the future to Ernest Rutherford. And in 1909, he found out that this couldn't be true either, because if it was like that, it would have collapsed. No, that's his model. He actually proposed the atomic nuclear model. This was his experiment. He had a very thin sheet of gold, and he shot some positive particles to it. Now, this is what happened. Some of them just got deflected to the side a little bit. Some of them just passed through. Just very, very few of them. While others got deflected entirely, but almost back to where it started. Weird, right? So, this was what he proposed. There must have been a compact nucleus and all the negative charge around that compact positive nucleus. The compact nucleus, he said, contained all of the positive charges of the atom. Now that is correct. This is very, very, very close to reality right now. And we call it the nuclear model. However, this had a few problems. If it was like that, then the atom would have collapsed. And we know that it doesn't, because opposites attract, yo. And then we had a guy named Niels Bohr come along. In 1913, and he suggested that instead of just a cloud of electrons floating around at random speeds, they were in orbitals. If this was the nucleus, then the electron orbited around it, and this was like the planetary orbit around the sun. So some of us call it the orbital model, but as you guys remember from a previous episode, this is Niels Bohr's model. If we go into the periodic table, you might remember these little atom models here. And we call it the Moore model, at least the correct term is. And it's a very, very helpful way of representation of an atom. It's very useful as I don't even know what to say about it. It's so good, and we use it primarily. Today's model is basically this, but we have a few updates to it that I won't mention yet. The orbitals are like that, and the higher you go, like the next element, lithium, the more orbital shells you get. So by now it has two. In beryllium, it's like not full shell yet. You see, as you progress up and up and up, there are more orbits, more, I guess, planets around the central nucleus, or electrons as planets, if you will. That's silver. And for gold, well, this is its Bohr model. It's just very good, and usually, like, you see this one, like when it just switches, not like a flat surface. That's the more accurate representation as we could have done, but there's more to it. Yes, there are these little orbitals and more of them in there. This is accurate, but it's not as accurate as today's cloud probability model. People use this because it's easier to use, and for a lot of animators, it's easier to animate. The highest element, organism, is like this. It was found in 2002 for the first time. It was simplified in 2002, and this is how it worked. That's all I'm saying right now. So that's the Bohr model. But back then it only had a little ball of a nucleus instead of the protons and neutrons. After that, Ernest Rutherford. Let me show you a photo of him again. Ernest Rutherford again came back. Whee! And he found out with further experiments that there were such things as protons in the nucleus. And then later, a guy named James Chadwick found out that there were such things as neutrons, the neutral particle charges. And now, this is basically what reality is. This is the standard helium-Bohr model, and as close as we can get to reality. But the more common nowadays is like an electron cloud, a probability, like it could be here, it could be here, it could be here, it could be here. I showed you this at the beginning of the episodes of this chemistry series, but whatever. You decide which one you prefer. I preferably use this, so for the next chemistry lessons, from now on, we will be using the Bohr model, or also known as the orbital model. We'll just call it the Bohr model since everyone calls it that. And that is the end of this episode. So, I hope you guys enjoyed this episode. And if you guys did enjoy this episode, please like, share, and subscribe to the channel if you haven't already. And start turning on your notifications so that you can get more chemistry episodes and the other topics of the episodes of this channel. See you then. Schnan out. Peace.